Alright, so let's start talking about forms of inference, or you might, say forms of argument. And let's just start with something that's also kind of a quiz on the material from the last couple sections. Is this a valid argument? No puppies are cute. Pepper is a puppy. So Pepper is not cute. Think about it a second. Gaze on this little guy. A puppy. No puppies are cute. Is this a valid argument? What about this? No rock musician has substance abuse issues. Keith Richards is a rock musician. Hopefully people still know who Keith Richards is, right? If you don't, Google him. Keith Richards has no substance abuse issues. Is this a valid argument? What about this? No dogs are lizards. Pepper is a dog. Pepper is not a lizard. No 2-year-old can legally vote. Ben is a 2-year-old. He's my 2-year-old. Ben cannot legally vote. Now look, I don't, I'm not in the room with you, so I don't know how y'all reacted. But I'm going to guess that some of you are probably like, okay, this one about the 2-year-old is valid. This one about the lizard and the dog, which is just weird, is valid. These two about puppies and Keith Richards are not valid. That's wrong. If you had that reaction, if that's what you thought, look, I'm trying to trip you up. I'm trying to make a point here. Don't feel bad about it, but it is wrong, right? Remember, validity is all about the structure of the argument. It's not about whether the premises are true or even if they're not entirely stupid, right? I quite like the Rolling Stones. I think Keith Richards is a great musician. He seems like a very smart person. Keith Richards has also had loads of substance abuse issues, right? Rock musicians are notorious for abusing drugs. Keith Richards is, well, maybe one of the more extreme ones, right? Supposedly, he once had to go back to rehab because the day he got out of rehab, his bandmate Mick Jagger challenged him to a drinking contest, and Keith Richards did not say no, right? These are stupid premises, right? I think puppies are cute. Look at this little guy. These are stupid premises, but validity is not about whether the premises are true or false. So, what this means is all arguments with the same structure are the same on the question of validity. If some arguments have the same structure, then they're all either valid or they're not. So what about these? These are in fact all valid. Now, they're not all sound. Remember, sound means valid and true premises. We can argue about puppies being cute, but I'm pretty sure this is false. I think it's false. I think this little guy's cute, right? Certainly false. However you define substance abuse issues, that no rock musician has had them. Heck, if you don't think Keith Richards has had them, there are people who abuse substances even worse than Keith Richards. Keith Richards, pretty bad. But there are worse people than him on substance abuse, right? So these are not sound. At least the first two are unsound because they have false premises, but they are all valid. If these premises were true, then the conclusion would have to be true as well. If no rock musician had ever had any substance abuse issues, and Keith Richards was a rock musician, then we would know he had no substance abuse issues, right? So what's my point here? Well, part of my point here is to just drive home something I've already said, just to kind of hammer it in, because I think it does need hammering, which is Validity is about structure. It's not about whether the premises are true or false. You know, a valid argument can have untrue, uncertain, or even flat out stupid premises. All we're saying with validity is if we take the premises to be true, the conclusion has to be true as well. But another point I'm making here, and this is the point that Smith is making in your book, is that certain forms of argument, certain patterns of inference are valid. And if we recognize that an argument uses only valid forms of inference, we know that the argument itself is valid. You know. There are also some invalid forms of inference. We'll talk about some of them. The trickier ones, the ones that trip people up, are called fallacies. You know, if you notice that a pattern of argument uses an invalid form of inference, which we'll talk a lot more about that next week, especially in Lecture 5, then you know it's an invalid argument. But for now, we're focusing on if you recognize a valid pattern of argument, you know if it has only those, it is in fact a valid argument. The form of inference in all the arguments I started with today looks like this. No F is G. You know, use whatever letters you want. I don't care. Talk about that in a second. I'm just using these because these are what Smith used. N is F, so N is not G. Now look, it does not matter what you plug in here, right? No $ is hashtag. This little letter here is an S set. You know, it's something that the Germans only use. S set is $. So no S. So S set is not hashtag, right? Doesn't matter. You know, I'm using an apple, or I would plug in some wingdings here. It just matters. This is the form. We can use whatever we want to represent it. Now, we want to learn to recognize valid forms of argument. You know, we'll talk a lot more about this. That's one of the things, especially when we get to symbolic logic. We want to see, like, what are valid forms of argument, what are not. We need to learn to recognize them. But look, this is a skill that you'll need to develop. And honestly, even when I look at these, I can't always pick out what's valid, what's not. Now, there are some methods for doing this that are really rule-based that will lead you very, certainly to seeing valid or not. There's also some quick and dirty tricks that will help too, right? Logicians don't always like these, but whatever, they're good to learn, especially when we're just starting out with this stuff, right? Logicians are a very fussy lot. I'm cutting out some of the fussier stuff from Smith. If you wonder why I'm cutting certain sections, it's just him being very, very fussy, very hair-splitty in a way that we don't really need. I am not a logician, even though I'm teaching a logic class. I wouldn't say that that's my area of specialty. I am not as fussy as they are. I think if a method works, it's a good method, right? So here's one method, that you can try with arguments. You can go through, and if you have these unfamiliar terms, you can sort of find replace, right? I had to look up the physics on this. I didn't recognize it myself. So if you don't recognize it, don't worry, don't feel dumb. I had to do a bunch of Googling to make sure I was getting this right? Leptons, baryons, muons, if you guys don't know, they're all these weird particles in physics, right? No leptons are baryons, muons are leptons, muons are not baryons, right? Now you might look at this. I can't see you guys' faces, but when I give like sentences like this in like my in-person logic class, there's always some person who look back who almost has their jaw hanging open in like panic and confusion, right? What the hell is this? How am I supposed to deal with it, right? But look, you can go through and find replace, and that will often help. You know, it's all about the form, so it doesn't matter what we put in the gaps. If you don't know what in the world a baryon or a lepton or a gluon or a muon is, who cares? Just find replace, but make sure you are being consistent, right? So first we replace our leptons, no A or baryons, muons are A. Then we replace our baryons, no A or B, muons are A, muons are not B, right? Then we replace muons, no A or B, C or A, C or not B. You know, and if you really know your logic, you can already recognize that this is, a valid form of argument. But if you don't, you can always just plug other stuff that's more familiar to you, it's not as weird, into this and see if it works, right? Just be consistent with what you're replacing, right? No dogs are B, C are dogs, C are not B. No dogs are lizards, C are dogs, C are not lizards. No dogs are lizards, beagles are dogs, beagles are not lizards, right? If this helps, this find replace method, Smith, and next week we'll emphasize this as a way of showing that arguments are invalid, but sometimes with valid arguments, until you practice this a little bit more, it will even be helpful with them, right? And especially if you don't know what kind of argument you're dealing with, because the words don't matter, because it's all about form, we can just do this find replace as long as we're consistent about it, right? And already, I think you guys can hopefully see that this is one of the ways logic can be very useful. And this emphasis in deductive logic and not thinking about what the sentences are saying, but only the form of argument, you don't need to go out and do a bunch of Googling like your, hardworking, very sacrificing teacher is doing. You don't need to do a bunch of Googling on muons, leptons, gluons. You just need to recognize the form. You don't need to know a thing about these particles. You recognize the form. You know this is a valid argument. You don't need to dig into all the stuff about what the particles are or aren't, right? So Smith talks about this, but I think it's good to go through these again. He talks about some valid forms of argument we've seen so far. Of course, there's the no F is G, N is F. So N is not F that we've spent so much time on, that I've sort of hammered very deeply into the ground. There are a few others, right? Mr. Smith is very, very English, and he's very upper class English. So I think it's reflected in his examples about the symphony and about Shakespeare. Nothing against the symphony or Shakespeare, I like both, right? Nothing against. I quite enjoy seeing Shakespeare plays, but they're very, very, very English and very upper class, right? So we can go with some other examples. All F are G, N is F, so N is G. Mr. Smith gives us his very upper class Englishman examples. We can go for some others. All dogs are mammals. Moxie is a dog, so Moxie is a mammal, right? All F are G, N is F, so N is G. More complicated, some F are R to every G, some F is R to any H, so G is not H. He has this example about, opera performances of Tosca. I don't even know what Tosca is, right? I know a little bit about opera, but I don't know what this one is, right? But, we don't need to do that. We can use another example, right? Some wise people distrust everyone who uses corporate speech. Wise people is our F. Distrust is our R. They have this relationship of distrusting them. That is the R. G is our people who use corporate speak, right? No wise person distrusts anyone who is trustworthy. We have our F again, wise people. We have our relationship between them and some other people, distrust. And we're saying they don't have this relationship of distrust with anyone who is trustworthy, right? So we can infer from that no G. So G is not H, right? G, people who use corporate speak, are not in this group. H, people who are trustworthy, right? This is very roundabout. When we start talking about relationships, it complicates things, but hopefully this is no longer Greek to you guys. If it is, one thing you might try doing, come up with your own examples, right? Find, replace some F, R, R to every G. Think about some group. Think about some relationship it might have to some other group, class of things, thing you might think about. Fill it in, right? No F is G, so no G is F, right? No Protestants are popes, so no popes are Protestants, right? If some pope was a Protestant, then in fact there would have to be a Protestant who was a pope. There aren't, so these work. I'll talk a little bit more about this form of inference, in the next lecture when I talk a little bit about some of the exercises, but don't worry about it for now. All F are either G or H, all G or K, all H or K, all F are K. This might seem like gibberish to you. I don't think that Smith gives us any examples of this, not even a very upper class Englishman example, so I'll just give you one, right? All violent criminals, that's our F, are either have poor impulse control, they're in this group G, people who have poor impulse control, or they're immoral. H, they're in this group H, people who are immoral. All people with poor impulse control had bad childhoods. All G, our people with poor impulse control, are also members of this other group K, people who had bad childhoods. All immoral people had bad childhoods. All people in this group H, immoral people, are also in this group K, people who had bad childhoods. So all criminals are also in this group, people who had bad childhoods. Look, this is a valid argument. I actually don't think it's sound. There are, I'm sure there are people who are just incredibly immoral who had great childhoods. Probably people who had poor impulse control who also had great childhoods, right? We all know some people who are very nice who have bastards for children. It happens, right? So this is not a sound argument, but it is valid, right? Now look, I didn't give you guys section 3.3 to read because this is one of those sections where I think Smith gets fussy and overcomplicates things. His point here, which he does not put in the best possible way, is that there are a bunch of patterns you might recognize in an argument. You want to make sure that you pick up on the relevant one. One of the things that actually makes logic challenging is that there's no magic formula for this, right? Logic is a hard subject for a lot of people because it has a foot in two sort of skill sets that we often don't think of as overlapping, right? It has one foot in math. It's very formal. There are exact rules. There are precise methods. It also has a foot in English, literature, things like that, because it often involves a lot of interpretation. It often involves a lot of like trying to figure out what people are saying. Um, we're not going. Smith doesn't emphasize the English interpretation aspect of it much at all. We're going to do a little bit more of that than he does, but we're probably still going to emphasize a bit more this formal aspect. But I want you guys to know, in the real world, this takes skill even with arguments that are sort of wrapped up neatly like the ones Smith and I have been giving you. But in the real world, it's even harder because arguments aren't going to be neatly wrapped up in the way they are here. They're not going to always neatly have this no, sum, all form. We'll talk about this no, sum, all, some, or not form a bit more when I go through some of the exercises. And especially when we get to like formal logic later in the semester, no argument's going to have that form, right? Look at this, right? If someone gave you this actual argument that I gave here, some wise people distrust everyone who uses corporate speak. No wise person distrusts any person who is trustworthy. No one who uses corporate speak is trustworthy. If someone gave you this argument in real life, it might look something like this, right? People who use corporate speak aren't trustworthy. Why do I say that? Well, there are wise people, my mom, for instance, who distrust everyone who uses corporate speak. And we all know that no wise person distrusts trustworthy people, right? If you saw this, we're not actually going to talk too much about with this sum, all, some, or not form, how to do this. We'll talk more when we get to the symbolic logic later. But if you saw this, you'd actually have to like sit back and translate and be like, okay, what's this person trying to say? How does it fit into these all or not, some or not statements that we've been talking about, right? That takes some effort. Only someone with bad morals or no impulse control would commit a violent crime, and everyone who has no impulse control had a bad childhood. What's more, people with bad morals all had bad childhoods. That's how we know that all violent criminals had bad childhoods, right? This is this argument here, but if you saw someone actually make it, it would be stated more in language like this, not using this neat all form that's so easily recognizable. What we would have to do, and we'll do a lot more of this when we actually get to formal logic later in the semester, is we need to translate, we need to do some interpretation to bring out the logical form. That's often a very difficult thing, and it's one of those ways that logic is very precise, English isn't. So sometimes it'll be like, well, is this person making a valid argument? Well, it depends on how we interpret what they say, because one way of interpreting it, one way of translating it, it's valid. Some ways of translating it, it might not be. We will talk a lot more about this. I just want you guys to be aware of this issue, though.